All right, today we're working on trapezoids, and as we have seen throughout the unit, keep in mind this first sheet is not something we're doing together. You're going to go back and fill it in on your own. But if you notice, there aren't many properties of trapezoids, okay? We're going to talk about trapezoids and then isosceles. So, on to the next page. Let's first talk about what a trapezoid is. All right, so definition, it's a quadrilateral, so it's a four-sided figure that has exactly one pair of parallel sides. Okay, a trapezoid is not a parallelogram because a parallelogram has two pairs. Trapezoid only has one. All right, so here's that's the one property. Exactly one pair of opposite sides are parallel. All right, so here's my diagram ABCD. It's a trapezoid. AB is parallel to CD. And remember, we mark parallel by arrows. Okay? So, on your own, see if you can figure out the missing angles in the trapezoid. I will give you a hint. Use what we know about parallel sides and consecutive angles. I'm going to pause the video. Try it on your own, please. All right, the one angle is 75 degrees, the other is 138. If you got that correct, you can go ahead and move on. If not, listen to the explanation. We know that in a parallelogram, consecutive angles are supplementary. Here, we're not going to use that concept for all four of them. If you notice, these two are not supplementary, okay, because those aren't sandwiched between two parallel lines, all right? The two sides, AD and BC, are not parallel. So I'm only going to use it when it's between the two parallels. So angle A and angle D are sandwiched between the parallel lines here. So those are supplementary. So 180 minus 105 got me my 75. Over here, B and C are sandwiched between my two parallel lines, so I got 138. Okay, so if you notice, think about it, I drew a line down the middle over my parallel arrows, and I'm working these two are supplementary, and then these two. Okay, let's move on. Now we're going to talk about an isosceles trapezoid. So an isosceles trapezoid is a specific type of trapezoid. Still only one pair of legs are parallel, but what we notice is that the other two, the two that aren't parallel, are congruent to each other. Okay, because think of isosceles. An isosceles triangle, the two sides that aren't the base are congruent. Same thing here. This side is congruent to this side, meaning same measure. And that's what tells us down here. AD is congruent to BC. Keep in mind that the other two sides are parallel. So when we were looking at doing the the parallelogram sheet, we saw some examples where you saw one side was parallel, the other side was congruent. And we said that's not enough for a parallelogram, and here's why. Okay, because here's a picture of a four-sided figure that has two sides parallel and the other two are congruent, and we see an isosceles trapezoid. Let's go ahead and turn the page. All right, so just like in an isosceles triangle, if the two sides were congruent, the base angles were congruent also. So then we know that in the isosceles trapezoid, the pairs of base angles are congruent as well. So I can say that D is congruent to C. I'm also going to say that A is congruent to B. Okay, so I have two sets of congruent angles. Okay, we only have one in a triangle because there's only three angles total. Okay, here I have four, so I can use that information. All right, so using that information that the base angles are congruent in an isosceles trapezoid, please pause the video and try to find me the measures of angle A, B, and C. Pause the video. Okay, and I got that angle C was 51 because angle D and C are congruent because they are the pair of base angles. And then to find the other two, I just subtracted it from 180, okay, because I know that D and A are going to be supplementary. So 180 minus 51 is 129, and then A and B are congruent. All right, another property. So property number one, base angles are congruent. Legs are congruent. Property number two, base angles are congruent. Property number three, the diagonals are congruent. So BD is congruent to AC. So that whole thing is congruent. They are the same measure. Likewise, the next property states that, hey, not only are the big whole diagonal congruent, but when they hit each other, they make something else happen. The pieces are congruent to each other as well. Not all four of them, but we see that AE and BE are congruent. And then ED and EC are congruent. Okay, so I'm not saying that one diagonal is cut in half. That is a property of my parallelogram. If you notice, B and D is not cut in half. BE is not necessarily congruent to ED. But what I did say was that the two shorter pieces of the diagonals are congruent to each other, and the two longer pieces of the diagonals are congruent to each other. Turn the page. So let's talk about trapezoids in the coordinate plane. Okay, we're just going to do two examples together. One of them talking about, hey, is it a trapezoid? The other one saying, is it an isosceles? So the first one says, use slope to determine whether quadrilateral is a trapezoid. So let's think back to a trapezoid. What is the one property of a Sorry, guys, I don't know if you saw that. My screen just went black for a second. It's okay. You didn't miss anything. You're back. You're good. Don't freak out. Okay, so my one property of a trapezoid is that one pair of parallel sides. So I'm going to use slope to prove one pair of parallel sides, and I can say, hey, I have a trapezoid. So as always, let's start by plotting our points. So A is at -2, 0. B is at 0, 3. C is at 6, 1. Sorry, 6, -1. And then D is at 1, -2. I'm going to draw it. Well, it's four-sided, so that's a good start. Okay, now I'm going to prove parallel. So I'm not sure, it's going to be opposite. So it's AD and BC or AB and DC. So pick one pair of opposite sides and start with that. Let's go ahead and start with AD and BC. So I'm going to do slope. So I'm drawing my slope step. So I went down 2. Since it went down, it's a negative over 3. Okay, so the slope of AD equals -2 over 3. For BC, I'm going down and over. Down 1, 2, 3, 4. Over 1, 2, 3, 4, 5, 6. Okay, so it's -4 over 6, which reduces to -2 over 3. Okay, so the slope of BC equals -2 over 3. All right, now in order for those two lines to be parallel, what has to be true about their slopes? They have to be the same. Are they? Yes, they are. So that proves to me, I can conclude that AD is indeed parallel to BC. So because of that, I can now say, that just those dots mean therefore, ABCD is a trapezoid. Why? Because I have one pair of parallel sides. So it's not just saying it is, it's understanding why. To prove a trap, you'll need one pair of parallel sides. And I proved that by showing that one pair had the same slope. Okay. Next question. Use slope and distance to determine whether quadrilateral Pqrs is an isosceles trapezoid. So let's think back. What makes it isosceles? We have one pair of parallel, and we have to have the legs, one pair of legs are congruent, not the same. Okay, not the same pair. So one of them has to be parallel, the other has to be congruent. Okay, so let's go ahead and plot our points. P is at 2, 1. Q is at 6, 1. R is at 5, 8. And S is at 3, 8. Okay, so we're going to prove, we'll do parallel first. We'll see if we have parallel, and then we will do length to find congruency. Okay, so slope. So I'm going to do SR and PQ. Now, if you're not sure which sides you're trying to prove parallel, do slope for both sets. Like first find the slope for PR and SQ. If they're not the same, don't automatically assume it's not going to work. Do the other two sides. But looking at this, I can see both SR and PQ are horizontal, so they're both going to have a slope of 0. If I can't draw a slope step, I can't draw a triangle, that means their slopes are 0. Okay, so slope of SR and slope of PQ equals 0. Okay, so that means that SR is parallel to PQ. So I have my one pair of parallel sides, check. Don't assume everything's going to work. You got to go through and show everything. And likewise, if you had done SP and RQ and found they weren't parallel, then don't just quit, try the other one, okay? All right, so now to find congruency, I'm going to use the distance, my length. So I know not SR and PQ because they're the parallel sides, so I'm going to do from here, so up over, so I went up 6 over 1. So if I'm doing my length of PS, 6 squared plus 1 squared equals PS squared. So PS squared equals 6 squared is 36. Was it 6? Did I count wrong? 1, 2, 3, 4, 5. Sorry, 7. 7 squared plus 1 squared. All right, so 7 squared is 49. 1 squared is 1. So the PS equals the square root of 50. Okay, so in order for it to be congruent, the other one has to be the same. So now I'm going to do RQ. 1 and 7. Okay, I see the same numbers. Let me just double check though. So I'm going to find the length of RQ squared is going to be equal to 1 squared plus 7 squared. Because remember, I'm using my Pythagorean theorem. 1 plus 49. Okay, so RQ is equal to the square root of 50. Square root of 50, not just 50. So what I can say is that PS is equal to RQ. So I'm saying my two lengths are equal to each other. So I proved congruent lengths. So therefore, I can now conclude that PQRS is an isosceles trapezoid because I have one pair of parallel sides and one pair of congruent sides. Okay, just a reminder, ladies and gentlemen, look over the characteristics. We're going to do practice problems in class with these characteristics, okay? So it's not just about remembering them, it's actually using them, which we will do in class time. But if you're not going to take the time now to look them back over and try to have a grasp on them, it's going to make that time in class harder. So you need to come in knowing that trapezoid has one pair of parallel sides. You need to come in knowing that an isosceles trapezoid has congruent legs. Base angles are congruent. The diagonals are congruent. The two smaller pieces of the diagonals are congruent. The two larger pieces of the diagonal are congruent. Those are the things you need to know when you come into class, and then we can use that time in class effectively to practice with that. All right, you're all done.